Hello, I'm Chris, this is Gross Models, and this is day 9 of 30 Days Lost in Space. Now, this is the board from yesterday. I've got some extra components to add on today. As ever, I'll let Alex explain what's going to happen today, and then we'll get on with the build.
Hello, incoming transmission once again from Inventor Corp. This is once again Alex. We have just received transmission from your ship that your code the last couple of days seems to be going well, and that's good because today we're going to be taking the code from and the wiring from 2 days ago and the code and wiring from yesterday and essentially combine them into one program that you guys can use to now hopefully be able to tell the different stages that your thing will be in using the RGB LED, which we used yesterday, so that you guys can see at every 25% mark, it should change colors to show you guys the status of where it's at, in case you don't have a serial monitor handy, which you might not always have.
So, we're using this circuit from yesterday, a circuit basically from a few days ago, putting them both together, although separate, on the board, and we're going to use it for different things. So I'm going to modify this somewhat. Now you may obviously notice that this isn't a single 3-color LED because of supply issues. They sent the incorrect wired LED, so that works the same way but in a bigger package. Now, because we're going to be using it for a battery level indicator, I don't want them clumped together as one. I'm going to have a line of them. So I'm going to rewire this slightly, tidy it up a bit more, and get these wired in as it says on the wiring diagram just here. Although I'm not going to exactly follow that. I'll follow the pin out pieces to it, but not the positioning on the board, because I want to do it a little bit different. Okay, here's a halfway update. I've rewired it and tidied it up. I've got the ground going down to this entire strip now. Still coming from there. I just used a longer yellow wire because it's a longer wire that I've got. We still have the red, green and blue lighting up the red, green and blue. But they're just all neatly in lines now using the ground for that one there. So that's that. Next up is the photoresistor and a single resistor, which are going to go down this end. And again, the one end of the resistor needs to be grounded, so we're just going to put that to there easily like that. I've used an extra wire to bridge across, but I don't need to do it. I can just go that way instead of going that way and then put another wire across. I'll just go across that way. So that's that. The resistor, again, doesn't matter which way round it goes because it's a resistor. So I'm just going to work up the board there a little bit with that. So one leg is connected to there. Actually, no, I'm going to move that in a bit to give me some room to play around. Actually, no, I'm going to leave that where that was and move that to the other end of this to give me room to play around. So I'll ground that all the way across to there. It doesn't matter which side we're using, as long as, you know, we're doing that. Obviously, if we're putting more things on, I might have to more closely resemble what they're doing. But from there, I need 2 more wires to connect up the 2 sides of this to the board. So yeah, actually, I'm going that side. How can I do this more easily? Can I go there and around there, or would it be easier to go around there like that? I think that's going to be the easiest thing, best way of me doing it. So we'll get that wire up there. I'm going to unplug it while it's not flashing away while I plug things in, because I've got to pay attention to where I need them to go. I need one to go into A0 because we're using A0. That goes to that side there. And the other one goes to 5 volts. Yep, just goes to the live, which I'm going to pull. If I can use my glasses of seeing to make sure I'm getting in the right hole. Yep, There we go, 5 volts. I've even used a red wire for that as well. And that's going to go into there. So, in theory, this is now grounded because of that. We've got the signal going, power going in and signal coming out to there where we can read it in analog. And it's all through and grounded. So we've got the lights coming on and the resistor doing the same thing. Now, for the coding and reprogramming and tidying up, because I don't need all the rest of these wires. So, I've tweaked it once more, taking the ground from this side with a shorter wire, so it just looks a little bit neater. So, it's running the RGB program from yesterday. It looks a bit different because they're in line rather than circular. This is the light sensing circuit from a couple of days ago. I've actually got 2 versions of the code up here. This is the new one, the one from last week, which has got the sensor thing on it. So if I upload that now, you'll see, if I go back to this view, that stops working. But we do have the new thing coming up on there. Let me go back to there. No, I need to set up a new screen to show you what's happening on the output. Right, that's better. So if I run this software, at the moment it's flashing the lights. If I click on upload there, then you can see it across the bottom screen uploading, and then we start getting the numbers come through there, which is the percentage again. If I cover it over, it goes up very slowly. If I let it out, it goes up faster, which is just the same as we did a couple of days ago with the battery percentage. Now we're going to be combining those 2 codes, so I'll unplug and turn it all off and show you exactly what's going to happen there. Alright, as an intermediate step, I've basically combined the 2 of them together. So I've copied across in here the sensor setup. I've still got the RGB color setup. I've got the void print battery percentage little mini program, and then the void of the RGB setup, program, and then setting up the pin mode for the onboard LED as an output, which I'm actually not using at the moment, so I can get rid of that bit. Let's get rid of that. So we're setting up the serial at 96, which we did before. We're setting up the colours of the pins for the LED colours as outputs. Then the loop, we've got the sensor value adding on to the battery percentage, the sensor adding to the battery all the time, and we're testing to see if it's fully charged. If it's fully charged, we're printing fully charged, and then setting it to be the same as it was last time. Otherwise, we're just printing the percentage, which we know how to do that anyway. Then after all that, we're still doing the same as we were doing, just flashing through the colours on the LEDs. Now, as you can see over on the numbers over on the left here, they're going up, but they're going up very slowly. The sensor is in light. If I actually put it under darkness now, after it just said 1019, you'll see that's now going up by 9 or 10 each step, as opposed to going up by 35 or 40 if it's under normal bench lighting. The reason for it's going up very slowly is because of all the delays in this code here. So we're delaying by half a second between every color change, and it's only at every color change that it's printing the battery thing. That's not going to be an issue going forward, because we're going to be getting rid of this whole chunk of code and putting in more logic program gate things. But for now, I'm happy that both bits are running on the same board at the same time, although they're not interacting with each other quite yet. Now I'm going to go into putting in some of the if-then code bits, which I'm going to type in off camera, but then go through them with you, so hopefully I can reinforce them into my own brain, as well as informing you a little bit as well. Copied across chunks of his program. I've not just done the whole thing, because I still had my base program in there as well, and I want to learn how to do it, but it's easier than just typing everything. So let's have a look through what we've got. We've got the sensor set up as I had before, the colours as I had before. This new void program, print battery percentage, is just a better way of doing printing the battery percentage rather than having to call it every time. There's these void things are basically little programs that you can call at any time just by saying print battery percentage, and it will then nip up and do this instead of waiting around and not doing anything else. Then we've got the void RGB, which I already had. Now the double get battery percentage is the cooling of it. So we're basically saying double to get the decimal points, and returning that number as a percentage. Basically, that's why it's that's what we did before when we did this. But this is just the quick way of doing it, rather than having to type everything in every time. So we've got this for setting the pin mode, setting the serial to do the screen, which you can see on the left saying 100%, setting the pin mode outputs, and that. So the void loop, this is the same as we did before, adding the sensor to itself basically as the battery level, and that's increasing it every time. Double percentage is get battery percentage, so we can just call it percentage now rather than that. So for the maths part, we've got a little series of if-then points. This is directly copied from him. I'm going to change this around in a moment. So we're looking if the percentage is greater than or equal to 100, because we're adding more than single digits. It might go over 100, so that's easy. We're calling the green light to come on, which, because of the way I've wired mine, it does exactly the same thing. It calls the green one. And then the battery capacity, it's prevent overflow errors. We're just making sure that it is in fact set to 100, and then we're calling the percentage 100 to prevent from displaying over 100, which makes sense because it is still adding to itself, so it should flicker between 100 and 105, 110, whatever, but then go back down again, but it'll just show it as 100. So if it's 100, do that. If it isn't, if the percentage is greater than nothing and less than 25%, so if it's in the first quarter, call the red light. That's what he's doing there, just calling the red and turning the others off, which does exactly the same on my board, but with multiple LEDs. The double ampersand there is similar to as we did before with the double equals, just to make sure it is actually equal to, rather than if you use a single one, it works in a slightly different way in this programming language. Right, so if it's 100%, it's going to be green. If it's 0 to 25, it's going to be red. And then if it isn't any of that, it will continue on. And if it's between 25 and 50, it's going to be apparently yellowish. If it's between 50 and 75, it's going to be bluish. And then we're printing the percentage on the screen as well. And then we're waiting for 1/10 of a second. Now, what I wanted to do, because of the way I've got this set up, I want to change the colours around. So yes, I do still want it to be green when it's 100%, because that makes sense to me. And I do still want it to be red when it's 0%. But these two I want to change around. I do notice that he's got that as 80, so dim it down a little bit to make that yellowish colour. That doesn't work for me on here. What I want to do, the way I've got this set up, I want the red and the blue to be lit up. So I want to turn off that one, and I'm going to turn that one on to 125 for now. We'll see how it looks. So basically the way I've got it programmed on the board, which I can in fact show you down here, if it's at 0, it's going to be red. If it's in the first 25%, it will be red. 25 to 50 should be both of those lit. And then 50 to 75, I want both of those to be lit. And then at 100%, I just want the green to be lit. So it should work its way up, basically. I could have all three of them come on. That's something I'm considering. In fact, yes, I'm going to do that. So we're going to have less than 50. Those two at 25 to 50, I mean, that less than 25. 25 to 50. All, no, because that wouldn't work for all of them, would it? No, I'd need more LEDs if I was going to do that. I might do that as the add-on project. So we've got first quarter, second quarter, third quarter, and fourth quarter, just that. So I need to change the 25 to 50. I've done. That's going to be 0. I only need 1 0 in there. If it's between 50 and 75, I want it like that, because I don't want the red on, but I do want the other two on. So that should be that. I'm going to upload that program now as is here. Let me push that button there, and we'll see what happens. Let me go back to that screen. No, that screen will do. I'll just move that so you can see that a little bit as well. So again, 19, 20, 25, there you go. 30, 31, 32, 40, 45. When it gets to 50, it goes to those two. 75 will be those two. Wait a minute, that's not right. I think I've missed something out. I've got 1, 2, 3 and 4. There should be 4 states. We've got green if it's at 100%, which it is now. 0 to 25, just the red one. 25 to 50. Oh, I've got red and green. I don't want that. I want the first two. No, not the first two. I don't want green on. That's right. Red and blue. Then I want blue and green. But that didn't seem to be what happened. Let me just put some extra spaces in there to tidy it up so I can see what's going on. Let's try it one more time. You've got red for 0 to 25. The red comes on. Looking at the numbers, as it gets to 25, 2, 3, 4, 5, those two come on. As it gets to 50, yeah, that's not. I think my brain is not working. I'm going to go through it again and come back when I know what's going on. Okay, I figured out where I was going wrong. There's not 4 states. There's 5 states because we have 0 to 25. 25 to 50, 50 to 75, 75 to 100, and actually at 100. So what I can do, I've done 2 different ways of doing it. The first one is what I've got programmed in there at the moment. If I run that now, I've changed the numbers, as you can not see because it's too small. Basically, I've changed it from 0 to 33%, from 33 to 66, from 66 to 99, and at 100%. So it's just about to go to 33 when 2 of them come on. Then when it gets to 66, those 2 should come on. Which is just about now. There you go. And then when it gets to 100, that one will turn off and that one will stay on. So that's one way of doing it. The other way I've got of doing it is to put in more states. So I've actually got first the red and blue, just blue, blue and green, just green. So I'm just going to put in some more code to put in an extra couple of if-then sections and change some numbers around, and we'll see if that actually works. Okay, so I've changed things around a bit. I've got rid of a lot of the colour comments because they weren't correct. So we've got if it's 100%, go green. That's good. If it's between 0 and 25, just turn on the red one. 25 to 50, turn on the red one and the blue one, which is next to it. If it's 50 to 75, just turn on the blue one. If it's 75 to 99, I thought I'd better not put it in as being 100, although these are also equal, so it probably will work. Let's try it anyway. Let's make that 100. It makes it look nicer, doesn't it? So if it's 75 to 100, it will do those. No, it's not going to like that. No, I'm going to kick that at 99 because it's going to be 100 all the time. So I don't want that middle one to be on. That will probably make that one flash very quickly. So we don't want the blue one flashing all the time. So if it's 75 to 99, put on the last 2. And then if it's 100%, go green. So let's send that through. I'll come back to the bench screen so you can see that. Hopefully you may even be able to see the numbers on the screen there as well. So I'm starting it off, running and receiving data, and red is on because it's at 0, 9, 10%, 15, 20, 1, 2, 3, 4, 25%. The second one comes on and the first one's still on. 40%, so when it gets to 50, that one should go off. Just like that. Then at 75%, that should stay on and the green one will come on as well. About now. There we go. And then at 75%, that one, no, not 100%, sorry, that one will turn off and it will just be green. Yes, so that works. So I understand how the logic programming works, and it even works in situ. So that's that. I think that's it for the day. I'll let Alex sign out as ever, and I shall see you tomorrow for the quiz. Thanks for watching. Bye bye.
Should work. So, since this is the end of week 2, it looks like you guys have a challenge to do tomorrow. Those details will be, I guess, coming out to you guys in the next day. So you guys can look forward to that. Other than that, next week, we're going to be doing a quick little security video, and you guys get to make a security access panel where you guys get to make sure that you keep all those aliens out of your electronic machines and doodads. So we'll be setting up a little bit of logic to make obviously a pin lock system and etc. But you guys look forward to that next week. So this has been Alex. Without further ado, I'm out.